this final example of interpreting NMR, proton NMR, we've got a formula C5H10O2 and we've got a table of data. So we're going to do exactly the same. We've got 2.18 here. We're going to go looking on our data sheet. We know that we've got oxygens, so we're going to pick out the likely suspect. So at 2.18, we're going to go R, C, double bond O. We're going to go C with a H. Then we're going to look at the integration value and say that there's 3 H's of this type. Then we're going to look at the splitting and see that it's singlet, so there's no H's next door neighbour. So that's our first jigsaw piece. Then we're going to move on to our next one. 2.59. It's probably still of this type. Oops, sorry, we're not actually moving on to that one, are we? The question asks us to go on to 3.3. And it says the chemical shift and the splitting. So let's find 3.3. That's probably this type because we know we don't have a Cl or a Br. So I'm going to write ROC with a H. And then its integration value is a 3. So 3 of this type. And the fact that it's a singlet means no next door neighbours. So that seems reasonable. 2 triplet peaks with no other splitting. So 2 triplets, remember, tells us CH2, CH2. And then it's put the pieces together. So remember my tip, CH3s must go at the end. So I'm going to do the CH3 and the C double bond O. And that was our orangey kind of peak from the beginning. I'll just put that in, hang on. That was that one. And then at the other side, I'm going to put the green one. So at the other side, we know we have a CH3 that's next to an oxygen. And in the middle, we've been told that we have 2 CH2s from our triplet. Does that give us everything we need? 1, 2, 3, 4 C's, 10 H's, 1, 2, 3, 4, 5 C's, I can't count, 10 H's and 2 O's, it does. So we've managed to very quickly pull together the structure of compound W.